Hello, everybody. We are here again. Today, I'm joined with Kartikey, and we're going to go through something that's really exciting regarding ExecuTorch. So let me just get started really quick. What is ExecuTorch? So ExecuTorch is an end-to-end solution that enables on-device inference across multiple platforms. And because Qualcomm is the top player in mobile, but we also have IoT, we also have XR, we also have a ton of other things. This fits very well with across our entire product line. So what Kartikey is going to start with today is he's going to go through the mobile flow, which is what we currently have released in the official ExecuTorch Git repo. And then I'll kind of show you the demo that we did on IoT, QCS 6490. This is the demo that we did at the PyTorch conference. And then I'll also talk about the state of IoT and what we're thinking about for the future regarding ExecuTorch. So yeah, go ahead, Kartikey. Take
Sure. And I guess maximum people or maximum folks actually see me first time. So I'm really excited to share my thing more or less on mobile. So I hope so. My screen is shared. Can team drop my screen on the, yeah, cool. Thanks team. Okay, cool. So today, more or less, we will go through how you can easily do, you can say, the clip model. So today our focus should be is obviously in more mixed of large language models, how you can do inferencing around it, obviously with not that big parameters, maybe minimum to minimum 1 billion parameters in a way. And I will also demonstrate how you can inference any model apart from it using ExecuTorch with QNN. So before going that, let me give you a basic demonstration that will be easy for you. Okay, cool. And so this is a basic app that I created. So it's obviously I'm using Clip Vision. So if you see, I take out my cam, and if I will see here, let me take a photo of it. Cool. And let me just, because generally in clip model we generally needs embedding so that we can use for the vector search and around that applications. And if I will do run inferencing, it will give me maximum minimum or like what are the variants of that particular image or around it, right? And this is the basic example that right now I wanted to show you how you can do. It is very smooth. I just needed to it is generally loading the model in a way. You can obviously quantize in a way, but obviously I'm not going into depth of that particular part. Yeah, but let's deep dive into the app or structure of the app. Cool.
Yeah, and just real quickly, so what is the clip model for those who aren't, we've been in LLM world forever, and it seems like.
Yeah, so okay, clip model generally it's a very so clip is very famous in the image, you can say image embeddings kind of research, you can say around that part. So what it majorly focuses on, generally we target two things, that is one is the image and second is the text part. So yeah, it has gotten the concept of the paper from OpenAI. So suppose, taking an example, you are in an Instagram and you see a lot of posts and there are some captions to it, and obviously use hashtag also while posting anything on Instagram. So what OpenAI teams came into play, they think maybe can we maybe take a reference of the hashtags also to give a reference to that particular image, what it image can be. Suppose I posted a dog image and I just write a caption, my love is dog, or like this is my lovely dog, something like that, and a hashtag something called dog, right? If we can regenerate or scrap the Instagram data and try to understand from text about an image, that's what clip model is. So if I'm taking in a picture and I'm maybe writing a caption on it, let's see how similar they are in a way, maybe in that purpose, and we can find out in that particular model. Yeah.
Oh, okay. Thank you.
Cool. Yeah. So let me deep dive into the structure of it. Okay. So before UI, okay. So obviously, you obviously have to decide your model view. That is a major thing that I created as of now. Okay, to get more around it. But yeah, let me go. So I just added some of the color texture to it. So I'm obviously not going into the each and every UI that I created. It's very easy to do. Okay. But the major thing is the you can say the clip inference part. Okay. So what we are actually doing here, okay, so before going anywhere else, let me give you some more knowledge about like what are the model. So there is also a directory called CPP, which is like the bundling part of it, C++ binding with QNN or GNI, what we call around it. Okay. If you want to understand the basic architecture, I will give you one instance around it. Okay. So generally, suppose there is maybe a CNN model. Okay, it is compiled, it is go through QNN model architecture, then it will build, and then model will build, and it transfer to the different delegations or target devices. It can be CPU, GPU, DSP, ST, or LPI, anything, and you can get make inference part of it. So this particular you can say Android app is focused on 2 to 3 layers. One is the Kotlin UI and JNI layer, and JNI layer is basically binding with the C++ part of QNN, how we are using CMake file to basically interact with the layer, ExecuTorch layer. And generally, as shared by Derrick about ExecuTorch, it's basically a mixture of the runtime with the different backends. So right now, obviously, Qualcomm is a great player in terms of when we say hardware part of it. So if you have suppose, so this phone that I use as of now is S25 Ultra, which gives you an inference part of it, and inside it there is a Snapdragon chip, and you can do on-device inferencing on top of it. And part of the Qualcomm QNN part, we have a three structure that we divided. One is HTTP/DSP. Second is backend, obviously, and third one is if you want to give a context to that particular model or not. Okay. Runtime, it can be .pt model, but again, what you can do, and that's the famous thing that what I want to share is the the QNN part. You can download this thing from. Let me share the link with the I guess the team. That will be helpful for them if they want to download it. Maybe I will drop in the chat so they can drop in here. Cool. And yeah, so majorly thing, you can download the QNN from here, but my major focus is to how you can use it from the part of DLC model, which is the Qualcomm hair model. How our models, or how our types of models can help you to build in a more better way. What I mean to say that the inferencing part becomes more better comparison to all other benchmarks, if you say in that part. Okay, so if you go to models and go to mobile, right, these are all the model that you can use it, obviously. Okay, and suppose if you want to, suppose I want to go for maybe pose estimation for now, right, you can use all the models on the mobile part, and you can download it, right. If I will search basically clip model, sorry, clear all, let me, and clip, yeah, open a clip, go here, and you can download the model.dlc. So if you see there, you will get the stats of that particular model. Obviously, you can use pytorch.pt, that is the pytorch type model, but you can also use that. It just improve your performance on the top, because we build this model on top of our hardware, obviously. So it will help you a lot in many ways. Okay. Now let's go back, because I give you a basic structure how it works in a way, so it will help you. And obviously, ExecuTorch, if you are going for the, suppose if you're using Llama 3.2 1 billion parameter model, you can obviously go with the tokenizing part. You can also do tokenizing and do sentence piecing part, which is going back to the front end part. It will show you the inference results. Okay, now let go back to our code, if you will say. So if you will see the major, if you will see to the files. Okay, obviously I am not saying like obviously I'm not saying I will explain each and everything part of it, but what I can explain you, generally these are the files that we using for the inferencing part with QNN or ExecuTorch. This part specifically is for the JN, or you can say Java binding bridge for QNN clip and DLC part. So if we go to the QNN inference CPV, right, I'm just showing you how you can, yeah, I know we are going back to C++, but that's how everything is going around in a way, because it helps to work on more on kernel side or delegate part more better, right?
We've kind of accepted that if we're truly going to be on the edge, we'll have to get down to C++ at some point. So we're here.
Yeah, definitely. And I know many people didn't love C++ in a way, but trust me, folks, like you will love it at some point, because when you start playing around with on the how you can work on the edge part with C++, the power of C++ in a way. But obviously, we are not deep diving into in that particular part. But what I'm doing here, I can give you a reference around it. So this, I created a map just to do the run inferencing part, and again the what particular image feature of clip model that I have to give. It's around that. Okay. Another part to it, suppose you wanted to, suppose obviously this part from Derrick part IoT, but I can give you some reference to it. So if you will go to this, these are the files which is very necessary. So when you download if you will see when you download the yeah, so when you download the Qualcomm AI Engine Direct SDK, it will open something like this. Not this, obviously. So yeah, let me give you a bit. So when you download the model, it will something open like this, and open in the, and these are the files. And if you will go to the library part to it, and there's an Android part to it, you will get these files, a number of files for different purposes. When you follow the documentation, you will get to know there's specific file that we follow if you want to do inferencing for Android, and these are the particular 4 files that you use. Apart from it, the model that we are using, obviously I added a lot of, because I do testing on different models. But if you go to models assets, there's a clip model. This is the OpenAI clip.dlc model actually, right? And this is the model that I am using to do directly inferencing for clip model. And and you saw that it's a very quick manner that we got the result about it, right?
And just one quick thing regarding, if you're getting models from AI Hub, and this is something that we're aware of, and we are working towards figuring this out. But you need to make sure that you have the matching. So those scale and .stub files need to
Yeah,
match the same version with which the DLC was created for the model on AI Hub. So if you're
yeah,
using, if those DLCs from AI Hub were created using QNN SDK, say version 2.28 or something, then if you're using 2.39, which is the latest QNN SDK, to try to run these models, you may run into some errors. So that's just something to be aware of.
yeah. Thanks for sharing that, Derek. Yeah, cool. So if we go up now, let's go to the main, as I explained. So what actually all the CPP file is kind of doing, it's just creating the C++ binding with the GNI layer, which is by the QNN actually. Okay. And ExecuTorch obviously for, so think ExecuTorch just like a runtime thing, so that any stack that is created by QNN, it will just helping a kind of a runtime to support to run on the inference part of it. Okay. So if we go to the clip model, okay, if you see, I'm just loading you can say the model from using, obviously I'm just basically initializing the model, if I will say this is the part to it. Okay. And majorly, so how the inferencing is happened, again, if it is not, so generally it's just a case sensitive thing. If it is not initialized, clip is not installed, so I'm just prompting a you can say a message around it. Okay. But if it done, so it will go on the release part to it. So the major thing is, yeah, this is the major thing, how the clip DLC is present. So I am loading the model from here, I'm taking the model here and passing it here, just to load the model. And it basically just copying the part from because generally there's two aspect in Android. When you do it, it can be, you can directly download the models and directly do inferencing part of it, or you can package the model around it to run on your mobile phones. Okay. And the rest part is, again, this is the part that I'm basically giving the context. When again, generally clip work in that way because it already incorporate the context bin files in a way. But if you want to do add extra contextualization for the clip modeling, maybe to make your model more better fine tuned in a way, you can do. So I added an extra context.bin file just to make it that, to make it more for my end. And I just converted the image part to, so I'm doing normalization here. So if everyone knows, the images are too heavy from right now the phones that we are using, so we have to normalize from, if it range from 0 to 255 pixel grade, so I'm dropping that thing to you can say 0 to 1, which is very necessary for us. Otherwise it will take a lot of time to do, because there are some of the layers to it. When we going for the convolution neural network, generally we press it down. The reason is being there is a lot of extra data that we didn't need as for the image concern. So generally what we generally do, or in any general machine learning practitioner will do, we convert that thing into grayscale and normalize it to 0 to 1 to make the process move better for the understanding part of it. Yeah. So this is the basic thing, and it's a like a basic modeling part, if I will say, in that particular thing. Okay. You obviously have a I am not going with the llama inference part of it around that part, but what I can show you how you can, I created a kind of a QNN manager, is something like how different models can interact with each other. Okay. So this is something like, if there any if you, it's just like a debugging file, you can say. I already this is the proper repo that I already have, and I posted it already, so you can run on it obviously. Okay. And after that, if we go to, yeah, manifest file. Cool. So these are the some of the things that I added for the external storage. If suppose if anyone wants to do internal storage, the size of the particular Android app will become more bigger. You can say it can be touch around 1 GB also. Again, it depends on how many models or multi-modularity you are choosing over it. Okay. And second part to it, and obviously what are the file providers? Obviously these are the things that you have to provide just to connect. You can say the manifest file majorly connect your to your Kotlin file, which is a kind of a backend file, you can say, in that particular manner. Okay. And more or less, let me give you yeah, so not this one, I guess. Yeah, it is initializing. So no, I guess this is the image part of it. Okay, so I created around it. But so the major thing that right now you have to more focuses on is the yeah, config files are very necessary. So this is the llama model that I'm showing you. Obviously you have to give a generally in if you're when we are saying llama 3.2 1 billion parameter supports on device inferencing on S25 Ultra. You have to be very peculiar about what backend or what escalator you're using. Suppose I'm using Hexagon NPU, and obviously these are the file it should be there. Generally, these files actually initializing the JNI and the C++ binding simultaneously. So these files are very, very important. Obviously, what I can show you one more thing. If we go to so this is the proper doc from PyTorch. So let me share this thing with you all so that we can drop in the chat. Yeah. So if you follow this, obviously I'm not going, yeah. And these are three things that it generally follows the more or less that we work on it. So you need have an Android NDK. If you don't know, it's like a support for on-device AI, you can say, in that particular thing. So if I will, not this one, I guess. Yeah. So this is the, if you see in the include section, there's an NDK, right? This actually file actually explain all the, you can say, the camera to like all the, you can say, the file that supports majorly on device inferencing. Obviously these things more or less you can download from SDK manager if you go here, right? And or like any, like the majorly thing is how the device manager or SDK manager is there. You just need to download it. Otherwise you can, if you can write also, what I can do for you, if you go here and just write Android NDK, it will give you, and you have to download it basically from here. It is very easy. If suppose your SDK manager doesn't have it, you can do it. Just you have to add this file and it will build it, because Gradle build is always an issue for Android. For those who are working on it in Android, they pretty much know about it. So this is the part you can work on it, and it's the stable version. It will work in maximum time. So if you want, let me share this link with you all. Yeah, just give me a moment. Yeah, cool. So if you see the major architecture that we generally follow is this one. That is the any model. We will do compilation. We will do build on the using QNN, which supports our you can say base accelerator. You can say, okay. And these models will transfer to the target devices. Again, it depends on, you have to run that thing on CPU, GPU, DSP, or you can Hexagon, STA, and different. We have going on a wide variety of space around it. So you can explain that particular thing. But apart from it, if you want to do some testing around it, this is the GitHub repo that you can take reference. I tried my best to make the documentation more better for you. So if you click on it, you will get an each and every bit by bit structure, how it is. So if you go to the basic project structure, you will understand from this part, right? And obviously this is the session we can do, you can say build along, but it will take a lot of time to collectively do it. Maybe we need 3 to 4 hours, something like that, to build on top of each and everything around it. So I am not going into that particular part, but this is the documentation you can take, and let me share the, I guess, the GitHub repo to you. So let me see. Yeah. And again, this repo, I'm hopefully I created README files that much so you can understand around it how the inferencing is happened. And if you want to download APK also, that's not a problem, guys, folks. So if you go to the release notes or the releases part of it, I kind of created a releases. So if you go to the recent, give me a moment, not this one, yeah. So recent one, if you will go and go to the asset part, there's an APK is there. You can download it. You can obviously try in your, maybe in your S25, which right now supports the on-device inferencing, and you can test around it if you want. I love contributions also. again, it's a kind of open source, so you can, if I love to have contributors more from different around angles, and let me know if you feel any stuck around anywhere. But yeah, this is from my end, and I guess maybe Derek can take over from here. But yeah.
Yeah, thanks, Kartikey. Okay, let me. So yeah, so I'll be going through the current state of IoT. Also, where I think where we can head in the future and where we're kind of driving towards. Let me bring my screen up. So I'll just start off with just a quick with a demo of what we showed during the PyTorch conference. Let me share my screen. Okay. There we go. Okay. So yeah, this is the demo that we showed during the PyTorch conference. And this is all running on our QCS 6490 or the Rubik Pi. For any of those that are wondering, and this is running completely on Hexagon. The model that we're running now, this is only a Llama 2 stories, 110 million parameter model, but let's just make up a story. Today, and this is story, so it's not an instruct model. It's just going to take off from wherever I start. Today was a good day because, and then yeah, let's go. And this is all running, as I said, on this, everybody's probably familiar with this device at this time. So this is where we're at right now. I did see a question come in regarding Qualcomm Linux. I brought this up using Ubuntu, but that's going to be the next thing that I try to do is bring it up using Qualcomm Linux, because then that will complete the pipeline from developer to production ready. For those that aren't familiar, Qualcomm Linux or QLI is essentially like our Yocto build, which will get you directly to production. So in order to make this happen, it right now it is a rough process, because as I said earlier, everything that we've built so far is around mobile. So all of our examples, there are some things, some CMake and some things that we'll have to update. So for example, we'll have to onboard these devices here in these 3 files. And yeah, there's going to be some information that is internal that you'll need to do that. So I've been thinking about how I'm going to, what's the best way to enable people to, actually help develop on this. If you're interested in getting ExecuTorch running across whether it's our IQ9, whether it's the QCS 6490, the IQ8, and in the future, our Arduino devices. So let me just share this build script really quick. You can ignore all of this, and I'm only going to go to the parts that really matter. So for this build script, so these are the important stages of building ExecuTorch targeting the QNN backend. So the first one, what I'm calling stage 1, this will be build your ExecuTorch core. You can use this after you git clone, which is going to be here. Once you git clone the official ExecuTorch, you can either run this build script as is, or you can do like me. I like to run these CMake commands just individually. Actually, I had to do that to try to figure out how to get this to work. But with these flags, this is important. So I like to set this install prefix to a separate directory, so it just doesn't install in the CMake out folder itself. You need build QNN on. You need to point to your QNN SDK root, which is what Kartikey said. What Kartikey alluded to. And then a lot of these other ones, say you like one that I always missed was I would do flat tensor and forget to do this one. It will warn you. It'll let you know, hey, you need to have extension tensor on if you have flat tensor. And same with, this was one that got added here recently. So when I tried to turn this on, it was like, hey, you need this guy. So it can be iterative, or you can just say, hey, I'm just going to run this build script. I don't want to have to deal with this. And then, of course, whatever Python environment, please set up a virtual environment, as I always say. So this is stage 1. You build ExecuTorch core. And then stage 2. So now you're going to target the Qualcomm specific examples. So once again, we're gonna have our source at examples Qualcomm, which is when you git clone the ExecuTorch repo, this is going to be in there. And then your build directory is going to be cmakeout examples Qualcomm. Once again, we're going to make this build type release. Now, this is important because this is something that I built it on one device, and then I started running into CMake issues where it couldn't find something when I tried to recreate this build on another device. And actually, a colleague, we were both kind of going back and forth with this, trying to figure this out. And it all came down to make sure you set this prefix path to tell CMake where it needs to look for all of the dependencies. So here, this is probably overkill, but I was like, look, dude, look everywhere. So there's a specific file that CMake is going to look for. That's going to be an ET install. There's going to be one in CMake out. And then, of course, we need this third-party gflags build. We needed to look here just for some of the build. And then the other stuff, so turn this, I have this off, enable logging. I can probably turn this off. It'll make things probably run a little bit faster. And then, yeah, so then you'll build this. And then this is going to, same kind of concept for the Llama specific examples, build this. Now, how we're doing this now, how our specific examples is set up. So the Llama examples, I can take a model like, so Llama 3 1B or Gemma or Quinn, and I can compile that model on my desktop, which is way more powerful than trying to compile on this QCS 6490. So for example, I can get a Llama 3.2 1B model completely compiled to PTE from Hugging Face in under 5 minutes. My computer at home is a beast. But for how we have things structured right now, this ahead of time compilation is actually done on the device. So what does that mean? Llama Stories 1B takes roughly probably almost 2 or 3 hours to compile just to get the PTE file. What does that mean for, say, if you want to compile a 1B, Llama 3 1B or Gemma 1B? That can take, during the PyTorch conference, because I really wanted to get Llama 1B, I would start it at 9 p.m. and it would maybe finish at 3, 4 a.m. So that's just forward looking. We're going to split this off so you can actually run this on a more capable system than the QCS 6490. Now, IQ9 is a beast. So that you may be able to run that efficiently and get something pretty fast. But anyway, back to where I was. So this is just building the ahead of time components. So if you remember, what we're doing with ExecuTorch is you take a PTH file from Hugging Face, or if you have even more important, if you have some experimental model, you're doing some architectural things that you want to test to optimize on device learning, on device inference, you can take that model and then you have to do you have to convert it to the intermediate representation. And then from there, you're going to, and this is all part of the ahead of time components. So then once you get the intermediate representation, then you're going to traverse the entire graph, see what can be delegated to QNN. You're going to lower that to QNN. Then you're going to get a graph that's compiled, a context binary that's baked into, essentially a context binary that's going to be baked into PTE, to the PTE file, that then can run on our device. That's a very high level explanation of the entire flow. But then, of course, we just have so back to the ahead of time stuff. Yeah, all of this is actually roughly similar. And I actually think this is overkill. I can probably get the ahead of time components with doing the ExecuTorch core. I noticed this the other day. So once you have that, then we have to actually build our QNN adapter. And this is what's going to interface with the C++, and Python. So we have these adapters that's real cool. Our engineers, they created this. And then we'll just have to do some copying. Like I said, you can actually just follow this build.sh script and it'll get you built ExecuTorch targeting whatever device. I'm going to do the IQ9 for those that have IQ9s. This will get you for the QCS 6490. And yeah, let me think. What else? So future, I kind of went into a few things for the future that we're doing for IoT. Oh, one more thing. So another thing that you need to ensure that you do is you have to set this ADSP library path. The reason you have to do this is if you're using Ubuntu on, say, QCS 6490, there is already a hexagon version that's pre-installed with Ubuntu. So what this means is, this is why I was emphasizing the mismatch, is that you may be targeting and you may have downloaded this SDK, but when you do an strace, you'll keep seeing there's a mismatch. There's a mismatch somewhere. You'll go all the way through strace, and then you'll see, okay, hold on, why is it calling this SDK from this, from this weird directory? That's when I realized that, okay, there's already a hexagon that's packaged with Ubuntu. So in order to make sure that it searches the correct path for the correct version that you want it to look for, make sure you set this ADSP library path. And it's real easy to do these exports. So you don't have to get too daunting. And this information is right here. So you can just easily say, in a shell, in whatever shell. We have a couple of ways to do this. Where am I at? Okay, yeah. Nope, ExecuTorch, QNN. So we have a couple of ways to do this. You can run this script and it'll automatically set all of the environment variables. So that's why you see here, I just ran this script and it automatically set everything. Another thing you can do is you can also go into, let's see, CD, QNN, SDK. Where am I at? Okay. Let me hide this. It was something in the way. And then what is it? Libraries or binaries? Let's see. Okay. You can also run this. Now, if you run this, it will automatically set up your environment variables, your QNN specific environment variables, but it's going to, and it'll give you a warning. Let's just run it and hope that it doesn't break anything. Hey now. Okay. Yeah. So it'll give you a warning that right now it's going to set the root to to cart SDK root. So then from here, because ExecuTorch is going to look for QNN SDK root. So from here, you can simply say, okay, let me just export. I want it to be QNN SDK root. And let's set it to cart. And there you go. Now you have your virtual environment, your variable. We already have ExecuTorch on here. So we can go ExecuTorch. Okay. I can't type. Oh, no, we don't have ExecuTorch on here because this is a different terminal. But anyway, you see how you can go. You can do that. And then, yeah, so this is key. And then also another key is to make sure that you set your linker path correctly. So if you're on Ubuntu, as I am, then you will point this LD library path to Arch64 Ubuntu GCC 9.4. I thought that I needed to install GCC 9.4, but I just ran it on another device where I had GCC, I think 13, and it worked. So I guess this is not as important as you may think. But for so these are just some things to be on the lookout for when you're trying to enable this on your IoT device. This is one of the key guys right here. Is this ADSP library, and point to the correct Ubuntu. Now, for the guy that asked about Qualcomm Linux, if we look in here, let's go back to CD libraries. If we look in here, theoretically, I haven't tried it yet, but these are going to be your Qualcomm Linux environments. So theoretically, if we point if we point our linker to one of these when we build, so instead of me pointing to Ubuntu GCC, if you point it to one of these, whatever is the compiler that you're using, theoretically, it should be able to compile for Qualcomm Linux. So I think that may answer somebody on YouTube asked the question about Qualcomm Linux. So you can follow these same steps, and then and that'll get you unlocked. Another thing also. So with this ADSP library path, and let me bring up the devices. So with this ADSP library path, it needs to match this version, needs to match the device that you're actually using. So I know for QCS 6490, it's version 68. But if you're using a different device, you can go here and let me post this. Actually, let me do this like this. My computer is lagging like crazy. See, this is why I need to have a Snapdragon X Elite for my work computer. Okay. So I'll post this link so you can get to this. And this is part of our AI hub. Now, what you'll do is you'll look for your particular device. So, for example, QCS 6490. So I know that it's version 68. That's the hexagon version that I need to point to. Now, if you're looking at IQ9, which is QCS 9075, then you need to set that ADSP library path to V73. So V73 will be V73. So instead of setting it to V68, set it to V73. And those are kind of everything that you should need to get LLMs or to get started with LLMs running on device. So future, looking forward, as I kind of said earlier, we really need to split, and we're going to work towards splitting out this ahead of time compilation part for QNN examples. If you're just running llama examples, LLMs, which will run also, then you can already configure. You'll have to change this will be x86. This will point to x86 CLang, but you can build it on your desktop and you can do the compilation. But for our examples, we'll have to do some changes to the build script to enable this ahead of time stuff, to be able to target a device and run it, and get the PTE file and then take that PTE to run on device. Also kind of excited about, we have some, of course we have Arduino, and we're just going to try to do ExecuTorch with everything. So of course Arduino is coming, so that's going to be real fun to bring up ExecuTorch. We have robotics. That's a real big thing that we're getting ready to move into, our team specifically. That's going to be real fun. We have the multiverse hackathons where hopefully you can use ExecuTorch across all of our platforms, because let me remind you, we have compute, we have IoT, we have mobile, we have XR, we have, whatever type of device that we have. So we want to enable the seamless deployment of any model using this. I guess, are there any questions? So thinking about maybe development. So I do have this what I've been working off of is, so this is the official ExecuTorch. So this will be the official ExecuTorch. But for these updates, these build scripts, because of course it takes a little bit of time to get pull requests pushed to official ExecuTorch on Qualcomm's behalf. So another thing that I've actually just forked, let me see, where is it at? I actually just forked this ExecuTorch. Here we go. And this is where I think I'll put all of these updates that I just showed, right now it's a mess because I was going between like a million different devices. I think this is the one that is most up to date. I don't know, but I'll clean this up, push everything to main. So if you want to actively develop, and this won't be as restrictive, of course, everybody's using the official ExecuTorch, so it has to go through a lot of different processes. But if you have things that you want to see done, we can work off of this one, and then we can help get your pull request pushed to the official one if you want to do it that way. I'm open to suggestions, and hopefully, internally they're also listening and they can take some. We can do something a little different. But this is just one way. And like I said, we have all of those build commands. I'll update with the latest information and push to main. And maybe we can just develop off of this guy, and then Kartikey and we can help get your pull request pushed to the official ExecuTorch as well. But yeah,
What I
that's
can
all I have. Mm-hmm.
what I recommend to folks, like maybe if you feel like very overwhelmed with the maybe a torch execute in a way like the repository, then what you can start with, maybe contributing to examples. That with one of the best way you can do.
Mm-hmm.
Maybe if you go to the Derek, can you go to the example part
Yeah,
of Qualcomm, if that
yeah.
possible?
I know one of the big things, speaking of examples, I'm glad you brought that up. One of the
Yeah,
big things that we're going to in the so let's just go to Llama. So after you get all of your builds, yeah, these are all of the models that are currently supported from these
yeah,
examples, as Kartikey mentioned. And we have some real cool, these hybrid modes where it's actually doing it's going to do basically this in is going to determine, so your initial prefill phase, it's actually going to chunk your prefill into a certain amount of blocks, and then
yeah.
do these. It makes the prefill stage faster. But yeah, go ahead, Kartikey.
Yeah, just wanted to share that only. So this is the best way if suppose any beginner is listening, suppose, or want to, or beginner in anything it can be, right? So if you are beginner in ExecuTorch or want to do on-device inferencing, understanding any example can be best way to do it. Generally, how anyone can go within open source world, right? So
Mhm.
what I can prefer, take any model, and if you think maybe from, or you can take obviously from AI Hub and try to maybe do using ExecuTorch and try to do it, and maybe create a PR on ExecuTorch, and we will have to obviously review it, and I guess we can push more better to meta team in a way. But yeah, that's I guess the best way to start engaging with Qualcomm's stack in a way, to
Mhm.
understand how it everything's work. And we are here to obviously, if you have any, if you're feeling you stuck somewhere, we are here to obviously at Discord and everywhere to
Yeah.
basically help you out. So yeah,
And maybe we'll do some offices, because once you start diving into this, maybe the
yeah,
next office hours, Kartikey, we can just take any
turn on
questions that people may have regarding
yeah,
ExecuTorch, and the models, and even just stuff like, yeah. So we have the CPP, the runner. This is going to be a runner. Maybe
yeah,
the next office hours can be focused around ExecuTorch, and the questions that
that will
people
be
may
good.
have, issues that they may have, and then we can bring that internal also and be like, hey, this is what people are seeing in the field. This is what we need to make better. So I think that would be a good thing to do.
Yeah. And folks try to we obviously are more majorly focus how we can build inferencing more better and better, right? But if you think like any capacity you get an idea, maybe you want to work around it, let us know. Maybe we can do some collaboration on that basis also.
Mhm.
So love to have you over there. And yeah, open source is always, I love open source, right? So anything, like if you want to contribute to my repo also, that's also a great way to start. To maybe those who are mobile developers and wanted to gets heads up around how they can implement a basic any model. That's
Mhm.
what I'm saying. Yeah, LLM is obviously is the peak on the point of like, if there's a lot of bigger parameters, suppose if it hit one more than one, like I guess recently there is a 1 trillion parameter came around it. But obviously on the edge devices, which include mobile, IoT, XR at some level, right? So the major point is how you quantize the model. That's a
Mhm.
major thing around it. And at the end of the day, there's a lot of thing, when we say quantization is very very important, it depends on the use cases that you want to work on, right? So suppose you are having llama model, which is one of the biggest model in a way, right? But you have to fine tune that model to a specific use case, which is, so fine tuning and quantization actually goes around the way. and it has helped you a lot in different use cases. So generally what we prefer, why edge is the future, it's not because like there's a lot of big model is available on cloud and you can use it. The point is, if you fine tune to a specific use case, it will give you a better solution than Gemini, or you can say any around the bigger LLMs at some point. And it is faster also, and it is privacy first, right? So you can work around it. Fine tuning and I can say quantization is one of the biggest you can say tools that you want to get into if you want to start with it, right? So that's what I want to share with. But yeah,
Yeah.
go on. Yeah.
Yeah, no, I was gonna say, and to tag along with that, because we got asked that question a lot at the PyTorch conference, like, okay, why the edge? And I probably said this to a million people, but I guarantee you that if somebody did a study, and maybe somebody can pay somebody to do this study, I'm gonna be modest. I'm gonna say 70% of queries, prompts can probably be served with the 3B model. So, or maybe an 8B model, which can run on the
Yes.
edge. So what are the implications of that? That means that now when you talk to, whatever your home automation device is, it can do, whether it's turning on the lights, you don't have to be connected to Wi-Fi. You don't have
Yeah.
to see this little thing spinning because your Wi-Fi got cut off for some reason. And then if it determines that prompt that you're the prompt that you asked it, or whatever you asked it to do, is too complex, then it can go to our cloud server, or
Yeah.
somebody's cloud server, to serve a more complex query. But I promise you, if somebody did that study, Kartikey, I
Yeah.
bet you, I'm gonna say 80% of prompts can be served by at least an 8B model.
Yeah,
So
like
that's just
I
another
like
case
I
for the
know
edge.
people fantasize about big LLMs, and yeah, it makes sense at some point. But if you will see generally for any use case, for any businesses that we see, it is very
Mm-hmm.
specific for one use case only. It's not like there are a lot of chunk around, there are a lot of things happening in a way. Right?
Yeah.
Suppose if you go for the suppose biological studies like protein part, right? It is very specific to protein. They didn't know about everything. Maybe it's happening. Maybe suppose maybe with sports and all, it doesn't matter to that particular stack in a way. So what I
Mm-hmm.
feel, fine tuning and quantization is the way maybe we can work around it. And obviously edge is the future, and it will help you a lot in many ways, because the point is privacy is a kind of a myth at this point at some level.
Yeah.
So this will help you a lot at maximum level to use edge solutions in that particular manner. So
Mm-hmm.
yeah.
Yeah. I say privacy, but I'm like, man, I don't know if privacy is compelling enough, because
Privacy
people,
is a myth.
people, when you say privacy, people are like, oh yeah, I care about privacy. But then you look at some of the stuff people do, and you're like, dude, do you really care about privacy or not?
Yeah, then
So
people then people are not using Instagram then at that point.
exactly. Um,
Yeah.
so yeah, and just to be clear, also, all of these models, when you do your ahead of time compilation, they are being quantized. So I think for this stories, it's quantized. I have the weights are 16-bit, and the activations, no, the activations are 16-bit. The weights are at 4-bit. You can also quantize to 8-bit on the activation, 8-bit on the weights. Of course, you'll probably have to do some fine tuning after that to bring the accuracy back up. But all
Yeah.
of these models we are fine tuning as a part of the ahead of time compilation, to get these models to fit on our IoT devices or on our mobile devices. But as you can see, even with the fine tune, it's running pretty performant,
Yeah.
from that example.
Yeah, otherwise there's a lot of methods in quantization also. Like if you are using AWT, like aware training, like before like
Mm-hmm.
quantize. So again, it depends on your use cases. If you can do pre-training before quantization, and after quantization you can do training also, pre-training
Mm-hmm.
in a way, right? So it depends on like what are the use cases, and again it depends totally how you are sourcing your data, or like how you are training your data in that particular manner. Sometimes
Mm-hmm.
you don't need a lot of data, a chunk around of some data, and algor you can say we can just do CNN at some point with some of data, and it is very fast at maximum model that we are using in a way.
Mm-hmm.
So yeah, the I guess fine tuning plus quantization can be a great way to do. But again, RL is coming in that particular manner, how we can make agentic
Man,
do better.
exactly. Who
Yeah.
knows? 6 months it'll be something new, and we'll all be pivoting to, that's what I actually like about this whole environment that we're in right now. It's like the wild, wild west, and it's like something will come up and then we'll
Yeah.
all like, oh shoot, we got to go in that direction. Let's see what's going on, So this is
Yes.
the fun part of this, So yeah,
Yes.
did we have any other questions, or man, I think this is the best I've done on time with one of these thus far. If not, we can let me shoot over to the Discord and see if there's any questions.
Sure. I hope so folks love it this time, but yeah.
Okay, I'm in there. Let me see. Yeah, so there will be a record. Yeah, so all of these Discord lives, they do live on YouTube. I was hearing myself talk in my headphones.
Yeah. I guess there's someone asked, "What? Okay, cool. What is the difference between the flow of AIoT plus AIMD workflow?" So, if I will tell you, folks, think in that way. Like ExecuTorch is basically a lightweight runtime for deploying PyTorch models or like the conversion models you can do, obviously, right, on edge devices. While when we say QAIRT plus AIMD flow focuses on optimizing and converting the model from Qualcomm hardware. So ExecuTorch. So if I will say in a smart or concise manner, ExecuTorch handles the execution part, and QART plus AIMT handles the optimization of hardware targeting. So they much more focusing on compilation, profiling, quantization in a way, and you can get an inference results around it. That's what AI Hub actually gives you as a dashboard kind of thing, right? You will get an inferencing profiling of each and everything around it. So yeah, I hope so that answers. Yeah.
Running on Ubuntu, I need to make Docker. Okay. Yeah, I see this. Yeah. So yeah, we have. So I see. Somebody was saying if I want the cart running on Ubuntu, I need to make a Docker. If my Ubuntu is on the PC, is 24. One thing. So how I was doing my ahead of time compilation, I was using WSL. Now, with that said, you can't run on Hexagon in WSL right now. That's something we are aware of, and hopefully that will change in the future. But yeah, there's some things that are, we are aware of them, and we kick and scream internally about a lot of the same problems that you guys are seeing, and they are on the roadmap, and people are aware, and they're slowly, making the changes that need to be. Yeah, endomorphosis. Yep. Yeah. We have some that we're using people have to set up paths and stuff like that. Yeah. So in the build, yeah, everything should be automatic. So I agree 1,000%. This is the state of where we're at right now. Oh, endomorphosis is going in. Okay. Yeah. Yep, this is all the stuff that we scream about internally. Oh, Llama, yes, please get Llama CPP, and that will save all of the Llama CPP on Hexagon. That will save all of our some of these issues. We will have a recording.
Cool. Okay, there is someone. I guess there's one more question. Okay. I mentioned there are now these 1.58-bit models. I was wondering if they are supported.
Yeah. Well,
Yeah,
I think that was everything. Mm-hmm. Oh, go
yeah,
ahead.
yeah, cool, sure. No. I'm just saying, like, obviously, I guess as of now it's not, but like what you can prefer around it, like you can do the conversion that we supports in a way. Yeah, have supports. You can do the compilation and you can do conversion model from one type to another type. So yeah, just wanted to share that.
And then, so we have, what is the difference between conversion flow of cart plus AIMET workflow versus ExecuTorch, and where does ExecuTorch? So basically, ExecuTorch, as it stands right now, I've gone through the I've probably combed the code, and I don't think so. Basically, cart plus AIMET is ExecuTorch is doing all of that. From what I've seen, I haven't seen any calls to AIMET in the ExecuTorch flow. So
Yeah.
you're doing your quantization, and that's what AIMET is essentially used for. Is for the optimizations that you want to do. But if you, like I said, if you look through the ExecuTorch repo, it is we're doing all of the quantizations and everything that's necessary. And I haven't seen anything that points to AIMET doing any of it. So I think those guys, they've really developed it, out.
Yeah.
So
What I obviously, so folks thinks in that way because obviously just don't think machine learning just a single thing. It is divided into, because the machine learning workflow is obviously a very big data augmentation, then training, then doing the inferencing, and in inferencing already have a lot of positioning around it, how we do MLOps kind of thing, right? So think in that way. If we are not saying we are not differentiating obviously at that point, but think like AIMT just gives you the model optimization part, how if you have any model that you built from training, how you can make that model more better so that it can inference better on the device, on the hardware devices, or you can on the Qualcomm hardware devices that we provide, right? Apart from the ExecuTorch thing, if you will say, it's majorly just think like a runtime in a way, how you can do the inferencing. There's a difference between optimization the model and inferencing the model,
mhm.
right? That's called the runtime in a way, right? So that's what is, if you say like, if you want to distinguish between ExecuTorch or AIMT in that way, I can give you that particular example on that front. Yeah.
Mm. Okay, so then there was another follow-up question. Okay, so this is where we kind of diverge. So if you're saying which workflow does Qualcomm recommend, then of course they're going to recommend um, the cart plus AIMET,
Yeah.
Genie and all of that. Now, if you're asking me which one do I recommend, that's a different conversation. So, and I'll just leave it at that. But also, because I Endomorphosis, he has some real good concerns. He's making some good points. And I'm sure there are a lot of people that feel the same. And it's funny because, we at the PyTorch conference, they just kicked off ExecuTorch 1.0. And we was at the hackathon and somebody was like, you know, now, of course, we're not going to be given the same grace because we're not PyTorch. But somebody said like, man, I remember when you guys first kicked this off, and things are way better at this point. They were really happy to see the progress that was made and where ExecuTorch ended up for
Yeah.
1.0. So I know, maybe people don't want to give Qualcomm the same grace. But we are fighting inside and we are making these changes as
I
necessary.
guess
So it's
can
going to
I
take
can
some
add.
time.
Yeah, I guess I can add to it more, like obviously people used to, because of some framework which started off with some companies and all way, right? But at the end of the day, what is the performance that you're getting? So let me, if I will share again my
Mhm.
screen to Qualcomm I have for now, or like the clip model, if I will say, right? So if you will see, this is the Onyx runtime, right, which is kind of giving you an inference time of 10.1 millisecond, which is okay, right? Like, which is a good, obviously, a good runtime. Let me compare this thing with TF Lite. It is like called 9.96, right? Which is also good. It's better. But when we say Qualcomm, and these are the inferencing is done on Snapdragon chips, which is used by maximum mobile developers, if I will say in that particular way. So obviously it depends on what target device that you're focusing on. And obviously because our models in a way optimized for specifically for our hardwares, which gives, obviously when we say independent also, obviously depends on the what kind of use case that you're picking up and what kind of problem that you're solving in that particular use case, and how the whole architecture built on top of it. So for something, maybe ExecuTorch is better. For some part, maybe if I will say our QNN part or QNN SDK is far more better than many folks out there. So obviously, it just focuses on what kind of use case that you're picking up. And again, if we talk about mobile apps, we are giving inferencing. If you compare the benchmark that I'm showing you at this point, right, it's just kind of better than others, those who are using it in that way. So yeah. Okay, last question. What framework does Qualcomm recommend to fine tune or deploy LLM efficient on Snapdragon hardware? I guess if you see Android, I already showcase you, right? I'm not saying it's a production ready app that I show you. It's like a demo app in a way. But I guess you just need the QNN SDK. You don't have to pick those file that you want to do it. If you're going for the hexagon NPU kind of side, obviously you have to specific file that I showed you earlier, like the specific file that you want to do for the inferencing part. Apart from it, deployment part, because we are doing on device, what is the question of deployment is that you're doing on your at the end of the on your phone in a way, right? So there is no question when we say deployment. Maybe if you came on that particular part when you're going on cloud, or maybe in a hybrid kind of cloud in a way, right? Then you can work on the MLOps side. Obviously we are not actually talking about that, but you can obviously go with different framework that you can use for MLOps part. But when we say deployment LLM efficiently, you are easily doing. Yes, when we say compare, so what I did with some of the testing with Llama 3.2 1 billion parameter, it worked well. It inferencing, it's happening, and it's in millisecond. I will showcase maybe in a maybe next stream somewhat around that particular part, but you will love it how it's going on that particular thing, right? So again, that's what I'm saying. When you're saying deploying, what context you are giving to it. If it is on device deploying, it's basically on your phone. It's happening, right? You don't have to maybe it's not like cloud. You have to basically upload your model to cloud, then it will do inference or create a workflow around it, right? You can say command automation kind of thing, CI/CD pipeline, something like that. So yeah, I hope you got that answer. Yeah.
All right. Well, I think that's a wrap, and I'll still follow the main stage, the chat, to answer more questions as they come back, as they come up. But I think, yeah, we can wrap this up for the day, and we'll see
Sure.
you next time. Any closing words, Kartikey?
It will be awesome for me. It's my first time, so I am really excited to see a lot of questions happening around. So it's awesome for me. Yeah. I hope so. I hope so. You all love that what we actually shared at the stream, and we will love to have maybe on that what we can think of the office hours. Maybe you can bring more questions. We will brainstorm on the office hours, and like let's see chat around it more and more. Yeah.
All right. Well, everybody have a good one, day, good night, wherever you're at in the world, and we'll see you next time.
See you, folks.